Now, before we leave this section on nomenclature, there are two more types of compounds that we need to talk about naming for, because they will appear commonly throughout the rest of the course. And these are common acids and binary molecular compounds. I'll give a brief definition of each. Acids, we haven't talked about these, we will in the next couple chapters, but acids are essentially a compound, we can think of it sort of as an ionic compound, where the cation is the hydrogen ion, so H+, and then that's combined with some anion. The way that we name these is simply by taking a couple different cases. If the anion that's present has an "ide" ending, then we change that "ide" ending to "ic", we add acid at the end, and we put the prefix hydro in front. What does this look like practically? Well, here are my anions, chloride or sulfide. Single monatomic anions, so they have the "ide" ending. If I add H+ to that, that will form a compound that I would treat then as an acid. And the "ide" ending is changed to "ic". I add acid at the end, and I add the prefix hydro. So this is for the case where my anion has the "ide" ending. Many cases, however, though, I have the polyatomic anions that contain oxygen and end with either "ate" or "ite. In those cases, I no longer add the prefix hydro. I still have the ending acid, and I change "ate" to "ic" and "ite" to "us. Again, practically, what does this look like? Well, let's take the chlorate-chlorite series of oxyanions. So here we have our perchlorate ion, our chlorate ion, chlorite, and hypochlorite. To make the acids of these by adding H+ to that compound, I change the "ates" to "ics. I don't change any prefixes that were already there. I don't add hydro in front. All I do is add acid at the end. I change "ate" to "ic" and add acid at the end. If it's an "ite", I change it to "us" and become chlorous or hypochlorous acid. Again, I don't change the existing prefix. I don't add hydro in front. I simply change these, the ending, the "ite", to "us", and then add acid at the end. And that's really summarizes how we name common acids. We can look at it in this way as well, where if the anion has the "ide" ending, I end up with the hydro prefix, the "ic" ending, and acid. If it's an "ate" ending, all I add is acid at the end and change the "ate" to "ic". If it's the "ite" ending, all I do is change the "ite" to "us" and add acid. And that's how we name common acids. Now, the second category is binary molecular compounds. These are not ionic compounds. They don't have a cation and an anion. They don't have a metal and a nonmetal. They're composed only of nonmetals. And they're composed of only two different elements of the nonmetals on the right side of the periodic table. Now, there's a systematic way of naming these. It does have some exceptions, but I'll try to go through those for you. So if we are going to name a binary molecular compound, one that has two different elements in various proportions, the element that appears farther to the left on the periodic table is usually written first. So if I were combining carbon and fluorine, carbon appears to the left, so it would be named first. Now there is an exception to this, and that is if oxygen is one of those elements and a halogen other than fluorine, so chlorine, bromine, or iodine is the other one, in that case, the halogen is named first, even though it does not appear to the left in the compound, in the periodic table. That is the only exception, however. Now, if both elements appear in the same column or same group, then neither one of them is farther to the left, so the lower one is named first. So if I have sulfur and oxygen, they both appear in the same column. Sulfur would be named first because it appears lower on the periodic table. Now, both elements are named simply with their elemental names. However, the second element, the one that appears last, That one, its ending is changed to "ide." Additionally, one more thing, Greek prefixes are added to indicate the number of atoms of each element that are present. And these Greek prefixes are shown here. So mono for one, di, tri, tetra, penta, etc., all the way up to deca. And so to give a couple examples, first is a compound that's got chlorine and oxygen. Now this fits our exception for rule number 1. Oxygen bound to a halogen other than fluorine. So oxygen is not named first. It is named second, and the chlorine is named first. We add a prefix, dichlorine, because there's 2 of them, and then add another prefix in front of to specify the number of oxygens, so mon, and then ox, and it becomes the "ide" ending, because the name of the second element becomes "ide." Nitrogen with 3 fluorines. Nitrogen appears to the left, so it's named first, nitrogen, and then trifluoride. If the compound that is named first only has 1 atom, we do not need to put the mono prefix in front of it. However, if it comes second, as in this case, we would put the mono prefix in front of it. N2O4, this would be dinitrogen tetroxide. The di for 2, the tet for 4, and nitrogen appears to the left of oxygen on the periodic table. And then we can even get all the way up to something like tetraphosphorus decasulfide. And that's how we name common acids and binary molecular compounds.